Okay guys, I'm going to be vodcasting here the solutions to homework 3.8p. Okay, and if you notice, special attention, this problem was taken off the 2008 AP examination, so that was last year's examination. So here we go. It says, in the boxes provided, draw the complete Lewis dot structures for the molecules represented above. Two different xenon-based molecules. We know that a couple strange things about this is it has a noble gas as a central atom in each case. So let's go ahead from left to right and let's do this using the rules that we've been learning and focusing on in class. So we got Xe, we got O, we got O, we got O. Xe is a noble gas, full valence. We know that O is 6 for its valence. Okay, so here we go. Initially, we're going to want to split, but if we split here, we're splitting to a double. So we do not split, we shift. Take one electron, put it over there. That allows this to bond here. We take one electron here, put it out here. That allows that to bond there. And we take one electron and put it out here, allows that to bond there. We're left with Xe connected to 3 O's. We're on a free response problem right now. So we're going to draw all of our lone pair electrons. And circle all these, and there's that. Let's go ahead and do XeF4, Xe. This one's kind of a pain in the rear end because all the lone pair is on F. Let's treat it as a halogen first just by putting its dots. In this one, we can split because we're going to be splitting to single bonds. So that's perfectly fine. We got Xe, F, F, F with the lone pair on the top. Okay, so here we go. On the basis of the Lewis electron dot diagrams you drew for part D, predict the following. Geometric shape for XeO3, that's going to be trigonal, pyramidal. Okay, and the hybridization of the central atom here is going to be sp3. And this molecule, again, this is going to have 3 sigma bonds and 0 pi bonds. This one over here is going to have 4 sigma bonds and 0 pi bonds. And the hybridization here, 1, 2, 3, 4, is going to be sp3d. They didn't ask us that, but might as well go ahead and do it. The hybridization of the valence orbitals in xenon. Okay, we just did that. There's 5 things here, so that's sp3d. And predict whether XeO3 molecule is polar or non-polar. It's going to be polar. I want you to justify your prediction, so we're going to say the lone pairs left on Xe bend the structure into an asymmetric position. Okay, so let's quickly review everything. We noticed that this was from the 2008 exam. We had 2 structures. Whenever they give you big boxes, know that you're about to be drawing some Lewis structures, so get yourself ready for that. You might want to review the splitting and shifting in your head. Question 1 asked for the shape of XeO3. Ended up being trigonal pyramidal. You had 3 bonds and 1 lone pair. The hybridization of XeF4 was sp3d. We know that because there were 5 regions of electron density around Xe. 4 of them were atoms. 1 of them was a lone pair. And XeO3 is going to be polar because the lone pair is on top of the Xe here. Bend it into an asymmetric conformation. Actually, XeF4 is going to end up being polar as well.